everyone, and welcome. If you've ever felt like you're fighting C++ just to get some basic stuff done, well, you're in the right place. We're going to move beyond the fundamentals and look at two features that will totally change how you write, read, and even think about your code. Let's start with a problem I know you've all faced: rustling with data. Okay, so you've been there, right? You need to manage a collection of items, maybe a list of students or courses, and you find yourself writing all this complicated code just to add a new one. You know the drill. Check the capacity, allocate a new, bigger array, copy everything over. It's just such a pain. But what if it was just this? One simple, clean line of code. This is where we're headed.
So this really boils down to two huge questions that separate basic C++ from powerful, expressive C++. First, how do we handle data that's always changing size without all that manual labor? And second, how can we make our own custom types, like a point or a complex number, behave just as intuitively as a built-in type like an int? The answers, believe it or not, lie in two of C++'s most awesome features.
All right, let's tackle that first problem. The answer is something called the Standard Template Library, or just the STL. Honestly, the best way to think about the STL is like a massive pre-built toolbox that just comes with C++. It's absolutely packed with tools to solve all these common programming problems, so you don't have to reinvent the wheel every single time. Okay, so what is this thing, really? The source material calls it a collection of C++ template classes. Now, the keywords there are template and classes. Template basically means they're like blueprints. A vector isn't just for integers, it's a blueprint for a list of anything. You tell it what you want to store, integers, strings, your own custom objects, and boom, it creates the perfect container for you. And the beauty of it is how all these pieces just click together. You've got your containers, those are the boxes that hold your data. Then you have algorithms, things like sort or find, which are the actions you perform on that data. Iterators are kind of like fancy pointers that tell the algorithms where in the container to do their work. And finally, function objects let you customize stuff, like telling the sort algorithm, hey, sort this backwards. It's a complete modular system that just works. So, let's zoom in on the rock star of the toolbox, the std vector. A vector is basically a smart array. It solves that exact problem we saw at the very beginning. It manages its own memory, automatically resizing itself whenever you add or remove elements. So you get all the good stuff from an array, like super fast access to any element, but with none of the headaches. And look at this. This just shows how ridiculously simple it is. You declare a vector of integers, and then you just push back new elements. That is it. No thinking about memory, no tracking sizes. The vector handles everything for you behind the scenes. It's clean, it's safe, and man, is it efficient. And this isn't just for, basic numbers. Here's a perfect practical example from the source code. A student class needs to keep track of all the courses they're taking. Instead of some clunky C-style array, we can just use a vector of course pointers. As the student enrolls in more classes, we just push back another pointer. It's a fantastic, real-world use case. Now, a vector is awesome, but it's not the only tool in the box, right? The STL gives you a whole range of containers, each one built for a different job. A vector is your go-to for fast random access. A list is way better if you're doing a lot of adding and removing in the middle of your data. And a map is perfect for key value pairs, like a dictionary where you look up a word to find its definition. The most important thing is just picking the right tool for whatever you're trying to build. Okay, so that's the STL. Super powerful. Now let's switch gears and talk about our second big idea, which builds on top of this. Now that we can manage our data like a pro, how do we interact with it in a more natural way? This is where we get to teach C++ some cool new tricks with a feature called operator overloading. Just imagine for a second, you've built a simple class to represent a 2D point, right? It's got an X and a Y coordinate. Logically, it makes sense that you should be able to add 2 points together to get a new point. But if you try to just write pt1 plus p2, C++ is going to throw an error. It has no idea what the plus sign means for your custom point class. But what if you could teach it? I mean, just look at the difference here. On the left, you've got the manual way, adding the components one by one. Sure, it works, but it's clunky, and it doesn't really capture the idea of what you're doing. But on the right, that's the dream. A single, intuitive expression that says exactly what you mean. This is the power of operator overloading, making your code actually reflect your intent.
So, what's happening under the hood? We're giving an extended meaning to an operator that already exists. And a really key point here is that we're not creating new operators from scratch. We're just taking operators C++ already knows, like plus, minus, equals, or even the output operator, and we're defining what they should do when they run into our custom classes.
So, how do we pull this off? Well, it all comes down to this. We define a special function. For instance, to overload the plus operator for a complex number class, you'd write a function literally named operator plus. Then, when the compiler sees C1 plus C2, it knows to translate that into a call to this very function. This function right here is the blueprint that teaches C++ the new trick. All right, adding is cool, but what about printing stuff out? Normally, you'd have to write some kind of print method and call it explicitly, like myObject.printRecord. It works, but it's not very elegant, and it's definitely not consistent with how we print all the other built-in types.
I mean, this is what we really want, right? To just use the familiar count with the cacal operator, just like you would for an integer or a string. This is the goal. Code that's clean, consistent, and totally intuitive.
And this is where things get really clever. Think about it. Cout comes before the operator. That means the function can't be a member of our complex class. And obviously, we can't just go edit the standard OStream class either. So we make it a standalone function. But wait, how does it get access to the private data inside complex? We declare it as a friend inside our class. This gives it a special key, letting it access the private members it needs for printing. It's a really elegant little workaround.
Okay, let's step back and put this all together. We've seen how the STL helps us manage data, and how operator overloading helps us create intuitive interfaces for that data. When you combine these two things, you don't just write better code, you fundamentally upgrade the quality of the C++ you write. So, what are the big takeaways here? First, use the STL. It gives you powerful, efficient, and heavily tested data structures so you can focus on your actual problem. Second, use operator overloading. It makes your custom classes feel natural and easy to work with. Put them together and you get code that's way easier to write, a whole lot easier to read, and far less likely to have bugs.
But really, if you remember one thing, it's this. These features let you elevate your code from just being a set of low-level instructions to being a high-level description of your solution. When you can write things like courses.pushback new course or PT3 equals PT1 plus P2, you're programming in a language that's much, much closer to how you actually think.
At the end of the day, the STL and operator overloading aren't just features. They're a total change in mindsets. They empower you to build code that isn't just powerful, but also elegant and expressive. So the next time you find yourself writing some clumsy manual code, just ask yourself, is there a better tool in the toolbox? Thanks so much for tuning in.